All right, this is day 5 of our unit dealing with basic circle knowledge in geometry. For the last 2 days, we've been talking about the relationship between arcs, which are little pieces of circles, and central angles. Today we're going to be talking about the relationship between arcs and something called inscribed angles. And here's the situation. So when I talk about central angles, I'm talking about angles like this one on the left. And this is the letter theta. We usually use theta to represent angles. And in this case, x is representing the arc, which maybe I'm going to color in red for a second. Okay, so x is representing the arc right here. So central angles, an angle whose vertex is at the center. It turned out that when it comes to degrees, the relationship between the central angle and the arc is that they are the same. If the angle is 30 degrees, the arc is a 30-degree arc. Now, on the other hand, these angles, like the one shown here on the right, are called inscribed angles. Inscribed. And inscribed angles are angles that whose vertices are on the circle itself. So if the vertex is all the way on the edge of the circle like this, that's an inscribed angle. And it turns out that the relationship now, the angle is not the same number of degrees as the arc. It turns out that the angle is half the arc degrees. So, you know, for example, I guess I need to make this a little smaller. If this turned out to be a 30-degree angle, then this would be a 60-degree angle. Okay, so either think of it as the arc is going to be double the inscribed angle, or the inscribed angle is half of the arc in this situation. So that's what the new concept is that we're going to be using to handle this assignment. And I'm going to be doing the odds from this particular lesson today. Starting with number 1, in the figure shown, which statement is true? Alright, to understand this problem, it is helpful to look at an example. Look, if you have two inscribed angles, and but they are associated with the same arc, like for example, this arc is 80 degrees. Okay, so, I mean, we just talked about the fact that when you have an inscribed angle, like focus on the pink angle for a second, the relationship is that the angle is half the size of the arc. So what will be the degree measure of angle x right here? Yeah, so since this is 80 degrees, then this angle is going to be 40 degrees. But then look at angle y. What will be the measure of angle y? Yeah, here again, since this is 80 degrees, this is an inscribed angle with the same arc as before. Again, this will be 40 degrees. So, the point is, even if we didn't know that this was 80 degrees, whatever this angle was, these two angles are going to wind up being the same. If this is 80, these will be 40 and 40. If this is 60, then this will be 30 and 30. So we don't need to know what this arc is. If you have two inscribed angles and they are reaching out and being associated with the same arc, the angles are going to be the same. So that is what is happening in this situation right here. Okay? So, for example, if I look at the red angle that I've just drawn, and then if I look at the blue angle I just drew, because both of those angles are associated with the same arc, arc SR. I don't need to know what arc SR is to know that angle P and angle Q are going to be the same. Scanning through these choices here, I'm looking, are any of these choices referring to angle P and angle Q? Focus your eyes on the center of these names. So for example, here's angle Q and here's angle P at the center. Okay, so angle RQS. Okay.
Morning time is 8:36. Thanks for stopping by.
Sorry about that. Angle RQS is the blue angle, RQS, and angle RPS is the red angle, RPS. All right, so answer B is the one that is true. Just for the sake of completeness, I want you to understand that it could have been done another way. For the same reason that angle P and angle Q are the same, it's also true that angle S and angle R are the same. Okay, because they both deal with arc PQ. So just understand that. Okay, moving on. Number 2. Find the measure of the indicated angle or arc in circle P. So for number 2, we are supposed to find the measure of arc ST. Okay. Arc ST is this arc right here. Okay, so that's what we're supposed to find. And so let's see if we can find it. Now this 61 degrees, that's an inscribed angle, and that inscribed angle pertains to this arc that goes, you know, from here to here. All right, that's this angle. Remember, the arc is going to be double the size of an inscribed angle. So this arc is going to be 122 degrees. Okay, the red arc here. So look at the semicircle aspect of this situation. Let's see if I can switch to blue real quick. We have a diameter here. So because this is a diameter, that makes this, you know, a semicircle. All right, just kind of going around from here all the way around to here. Okay, that's a semicircle. So that whole thing is 180 degrees. So if this red part is 122, that means that this yellow part over here, I should be able to subtract from 180. So if I go 180 minus 122, okay, that should give me ST. And that is 58 degrees. Okay, but you know what I just realized? Didn't I say I was going to do the odds? I'm just supposed to be doing the odds right now. So that was a bonus, man. But I won't be doing that anymore. So, looking at number 3. Alright, so for number 3, we are supposed to find the measure of arc AB. So, you know, if this is arc AB going from here around and down to here. So fine, that's arc AB. But we really have to start with what we are given. And what we are given is this angle right here, this 20-degree angle. And it is an inscribed angle here at the edge of the circle. So we know the relationship between an inscribed angle and the intercepted arc. So if this angle is 20, what will be the measure of this arc? It will be 40 degrees, all right? This arc is going to be double the size of the angle, so that's going to be 40. Now once again, you see the semicircle happening because this is a diameter. So if this is 40, what does that leave for the other arc? Yeah, that leaves 140 degrees. Okay, that must be 140 degrees because it has to be a total of 180. So yeah, that's it. So the measure of arc AB is 140 degrees. So that is your thought process. So look at number 6. Okay, all right, I see we have a diameter. So again, watch out for your 180 degrees semicircle. Now, this time we're supposed to find the measure of angle A. The measure of angle A is this angle right here. So that's our target, that's our goal. Now, because of the whole semicircle thing, you should be able to tell me right now the measure of this arc BC. Can you not? Okay, yeah, because of the semicircle effect, all right, just to emphasize it a little bit, I guess, we have the semicircle happening right here. There's my diameter, and here's my semicircle going like this. Okay, that's 180 degrees. So if this is 54 degrees over here, what does that leave for the red angle over here? I think I can get rid of this now. Well, just subtract from 180, yeah? So go 180 minus 54, okay, and that should tell you what arc BC is. So that's 126 degrees. But we are supposed to find the angle, measure of angle A, and of course, we know that the relationship is it should be half the size. So if this is 126 degrees, half of that is 63 degrees. All right, so that was number 5. Am I missing stuff? Okay, let's talk about number 7. We're supposed to find the measure of arc VST. Okay, arc VST is the arc that goes like this. Okay, that's arc VST that we have to find. So let's just play around with these numbers and see what we get. Look at this 51 degrees that we have on the inside here. Okay, if this is 51 degrees, this angle is associated with this intercepted arc right here. Okay, so if this angle is 51 degrees, we know the arc should be double that, so that should be 102. So this arc is 102 degrees. Now, look at what we have here. It looks like we have every arc on this circle except for arc ST. So let me back up and put a little bit of red on that. So the arc just from S to T, from here to here, that is the one missing piece. We've got the 39, the 102, the 135. The arc from S to T is the only thing missing. So I should be able to find that by doing 360 degrees minus everything else. So if I do 360 degrees minus 39 minus 102 and minus 135, that should tell me what arc ST is. Alright, so I could do all that subtracting just like this, hit enter, and I get 84. Okay, so that means that arc ST up here is 84. Now, don't forget what we were supposed to find in the first place, the measure of arc VST. But now that I have everything, finding VST should be easy, because VST, shown here in orange, is just the 39 together with the 84. Okay, so just add those two together, and that should be it. So that's why arc VST is 123 degrees. Okay, moving on to number 9. All right, well, find the measure of the indicated angle or arc in circle P given that arc LM is 84 degrees. Let's mark that. Arc LM is 84 degrees. So from here to here, all right, that is 84 degrees. And arc KN is 116 degrees. Okay, so KN. All right, I gotta make this a little bigger. Okay, from K to N is like this. All right, here is arc KN. All right, and that is 116 degrees. Now, we have to find all this stuff, okay? So, all right, let me see if I can do it one piece at a time. So, we need to find the measure of angle MKL. Okay, so angle MKL is like this. All right, so if I want to find this inscribed angle right here, you know that this angle should be half of the intercepted arc. So if this is 84, then this is going to be 42 degrees. Okay, so that is the answer number 9. It is 42 degrees. All right, let's see what else. For number 11, we're supposed to find the measure of angle JKM. Let's see where that is. All right, well, angle JKM is this angle I've just highlighted in green. Okay, it's this angle right here, JKM. All right, well, this is going to be a little more tricky because the intercepted arc for JKM is this arc that I'm going to show. I need to make this a little bit bigger. Okay, the intercepted arc for angle JKM is the arc that goes like this. It's the one that I'm showing it here in green, but it goes from here all the way around and down to there. And we don't know what that is right now. All right, we know this blue arc and we know this arc, so we have to think for a second about how we can find it. And you know, some of this information can be distracting. I almost feel like I want to erase some of it to make it clear to you. Here's how we can find the measure of this green arc I just drew. For temporarily, I'm going to erase this blue because that's not really going to help us. Maybe I'll even get rid of this angle right here. Okay, because I think that'll just distract you. And I think I'll even get rid of this. Whoops. Okay. To know what this arc is going to be over here, semicircle. You need to use your semicircle information. So looking at the semicircle, you see that we have a diameter right here like this. So here's a diameter. So that means I've got this this blue semicircle that I'm drawing. It goes all the way around like this. Okay, kind of messed that up a little bit, but you get the idea. So of course this semicircle is 180 degrees. So this 84 degrees, this red part over here, is one part of the semicircle. So you know that if I want to find the other part of the semicircle, all I need to do is subtract. So if I do 180 minus 84, that should do it. So if I go 180 minus 84, that should find me the measure of this green arc right here. So obviously that's going to be 96 degrees. Okay, so this green arc is 96 degrees. Maybe I'll just put it inside of there real quick. Alright, I'm going to put it right here for now. So this arc is 96 degrees. Now, if that is 96 degrees, then I should be able to use this arc to find the angle that we were being asked to find in the first place. Because the angle should be half of this arc. That's why this angle will be 48 degrees. Half the 96. So, number 11 should be 48 degrees for that reason. So look, you can see the thing that makes some of these problems difficult is not that the question you're being asked is difficult. It's that there's a bunch of additional information. All these lines and angles and arcs all over the place make it hard for you to focus on the part that's important. So I would really recommend using highlighters or markers or colored pencils, things like that. So you can do what I'm doing and sort of color in and focus just the part that you need. Alright, let's look at number 13. Angle LNM. Let's see where that is. LNM. Okay, this is going to be a relatively easy one. Okay, let me get rid of some of this extra stuff that we don't need right now. Okay, I'm going to get rid of all of this for a minute. Yeah, so angle LNM is this angle right here that I've shown in red. And as you can see, it is the angle that has this 84 degree arc as its intercepted arc. So again, the relationship is an inscribed angle is always going to be half of that intercepted arc. So if this is 84, then this is going to be 42. Okay, so LNM is 42 degrees. So last one from this group, we need to find arc LKJ. Okay. Oh, another easy one. Yay. LKJ, going into highlighter mode, LKJ is going to be this arc right here, from L round through K and then back to J. But hopefully you can plainly see that that is simply a semicircle. So that's going to be 180 degrees. Alright, that is how you do that. Alright, for the next problem we're going to need one additional piece of information. There's a such thing as having a polygon that is inscribed in a circle. If a polygon is inscribed in a circle, then every vertex of the polygon is on the circle, like this. Now, there's a principle, a theorem, that applies whenever you have this situation. And I'm looking down here at the bottom. A quadrilateral, meaning a four-sided figure, can be inscribed in a circle if and only if its opposite angles are supplementary. So for example, looking at example 5 here, of course a supplementary means it adds up to 180 degrees. So in other words, like angle B and angle E, they have to add up to 180. Angle A and angle C, they have to add up to 180 because they're opposite angles. Alright, and it's inscribed in a circle. So getting back to the paper, number 17 is like this. We have a quadrilateral inscribed in a circle. So here in number 17, these opposite angles must be supplementary. So that means these opposite angles must add up to 180 degrees. That will give me equations like this one. 2x plus 64 has to equal 180 degrees. All right, they're supplementary. I would solve this by subtracting 64 from both sides. So that will give me 2x equals 116. And then I would need to divide both sides by 2, like this. So that is going to give me x equals 58. All right, so that's one of my two answers. I need to find y also, but it's going to be pretty much the same thing. Maybe I can squeeze it in on the other side. Okay, so I'm going to do almost the same thing again. 4y plus 64 should equal 180. Opposite angles in a situation like this are supplementary. So once again, I subtract 64 from both sides. Once again, that is 116. But this time I'm dividing by 4. So I'm going to get y equals 29. All right, that's number 17. Let's move on. Take a look at number 19. Okay, this is the same thing. It may be a little bit more complicated because of the binomial that I have to deal with. And in fact, I'm going to create more space for myself in which to work. Okay. So when I go to do this problem, first I'll do the easy equation. The easy equation is looking at the 63 and the 3x. Those are supplementary. So 3x plus 63 is going to have to equal 180. Subtract the 63. That's going to give me 3x equals 117. Time 2 divide by 3. And that's going to give me x equals 39. Okay, that was the easier of the two. Now, for the other two, you know, we're dealing with the 65 and this 4x minus 1. Still, they are supplementary, so I need to make sure that they add up to 180 degrees. So I'm going to do my 4y minus 1 plus 65 is equal to 180. Now these parentheses are not really doing anything, so I could just erase them. Bling, bling. And now hopefully you can see that I can just combine my like terms. So this -1 and this positive 65 can be put together. So that's going to become 4y plus 64 is equal to 180. So we're back to this type of thing again. Subtract 64 from both sides. So that's going to give me 4y equals 116. And then we go ahead and divide that by 4. And that's going to give us y equals 29. Alright, so those are the two answers to number 19. Okay, let's see, what about number 21? Alright, remember, inscribed angles. Inscribed angles are half of the intercepted arc. So let me go after the x value here. And I'm going to try to highlight things to make it more clear for you. Alright, so the angle where this 12x is this angle that goes like this. Okay, it goes from here, it goes like this. Okay, so it's this angle. Let me make it real clear. Alright, that is the angle where the 12x is, this angle that I've made real red. Now, the arc that goes with it, I'm going to also draw in red. So here's the intercepted arc for that angle. It goes from here all the way around like this. Now, if I knew the size of this arc, I could just divide by 2, and that would give me the angle. But of course, I can easily find the size of this red arc I just drew because it is 96 plus 48. Okay, so I can just do 96 plus 48, and that is 144 degrees. Okay, so this red arc here is 144 degrees. That means that this angle should be half that. So this angle should be 72 degrees. Okay, so now we're down to the bottom of this. The angle is 72 degrees, but yet the angle has the expression 12x. Well, that would only make sense if these two things were equal to each other. So, in other words, 12x must equal 72 degrees, since we know that this angle is 72 degrees. 12x equals 72 degrees. So to find x, all I have to do is divide by 12. So if I then divide by 12 on both sides, that's going to give me the value of x, which of course is 6. Okay, so that's one of the two values that I need. Now I'm afraid I'm going to have to erase all this so we can focus on the other angle. So I hope you got all that down, because I'm going to erase now. Alright, well now we are supposed to find y. So look at this angle 3y. Let me highlight it for you. The angle that's 3y is the angle that goes like this. Okay, there is the angle where the 3y is. Now, here is the arc that goes with that. I'm going to make that the same color. Let me go a little bit bigger. Alright, the arc that goes with that is this arc right here. This is the intercepted arc, is the way we say it. Okay, so we have the angle and we have the intercepted arc. If I could know what this arc is, then I would know I could just divide by 2, and I could set that equal to 3y. I don't know. Look, this 48, let me put a little dot, a little bump here. This 48 only goes from E to F. That's the 48. But at this moment, I do not know this part of it, the part that goes from F to G. So I really need to figure that out. Well, look at the rest of the circle. 48, 96, 45. Turns out we have every other arc except for FG. So that works out fine for us, because then if we have that, we can just subtract from 360. So if I just do 360 minus 48 minus 96 and minus 45, that's going to give me the angle that I need. So let's do that. So that would look like this, and that gives me 171 degrees. Okay, so that means this is in fact 171 degrees. Let me erase the question mark and put 171 degrees. Alright, that's a little awkward because we have to divide that by 2, and I see that's an odd number, so it's going to make a decimal. But whatever, that's what you got to do. So if I divide this by 2, so I can get this angle, that's giving me 85.5. Okay, so 85.5, that is the angle, that is the 3y. So in other words, 3y had better equal 85.5. So if I want to get y, I'm just going to divide by 3. Okay, so that's going to give me y equals 28.5. Alright, so x is 6 and y is 28.5. Alright, and that is the end of this particular lesson. As you can see, these problems are getting a little bit more complicated. They take a little bit more thought. It's mostly because of how all the problems are sort of overlapping, and you have to erase one problem to work on another. Again, use your markers, use your colored pencils or your highlighters to just the way I do, so you can show which angle goes with which arc and sort of ignore everything else. We're going to need more practice on this, so definitely watch the next video, which will probably wind up going back and doing the even problems that we skipped over. If this video has been helpful to you in any way, please go ahead and hit that like button, give me a thumbs up. I really appreciate it. It helps me out a lot. Alright, I will see you in the next video.